Okay, guys. So this week we will be learning about the area of a regular triangle. And we're going to try to prove a formula for the area of a regular triangle. So we're going to first draw a triangle, a equilateral triangle, also known as a right triangle. And we're going to call its side A. Now, how do we figure out the area? Well, if you recall that the area of a regular polygon is equal to, let's use black, is equal to 1/2 pH. And the P is the perimeter. So in this case, the perimeter would be 3H, right? And then the apothem would be, so to find the apothem, we first need to divide it into, we first need to divide the triangle into 3 separate triangles. So we just do that. And therefore, the apothem is going to be this length. Let's make it a different color. And therefore, the apothem is going to be this H right over here. And in fact, in general, we can see that the area of this triangle right over here, the area of this triangle. So I guess from this diagram, you can find we can kind of see, you know, the area is this green triangle right over here. This green triangle. This green triangle times 3, right? Times 3. Therefore, to find the area, we really only needed to find the area of one of these triangles. The area of this flat-looking triangle. Well, that's awesome, actually. And therefore, we have of height H. So let's do that. Now, we don't know what kind of triangle it is, so in fact, let's just go ahead and label some angles. So we know that we know that in an equilateral triangle, all the sides and angles are the same. So therefore, let's draw a better one. In particular, this angle has to be 6 degrees, and likewise, all these must also be 60 degrees. And we also know that the length must also be the same. It looks, well, how do we know what this angle is? We want to find out what theta is. What's theta? Well, it seems that we can just divide this angle by 2, huh? So it seems that if we call this alpha, theta seems to be equal to alpha over 2, isn't it? So and we know what that is actually. We know what alpha is. That's equal to 60. So that's equal to 60 degrees over 2. Therefore, this angle is equal to 30. And since all the angles are equal, we can also conclude that this angle must also be theta. which is also equal to 30 degrees. All right. I think we got everything. Let's try it. Now let's try to find the area of this triangle. So the area of this triangle, the green triangle, is equal to 1/2. Okay, let's use our blue color. Is equal to 1/2 base times the height. Well, we know what base is. We know it's going to be A. What's height? Well, to do that, we're going to need some little bit more information. So what we need to do is we actually going to take this triangle. We're going to take this red triangle to find the height. So let's do that right over here. So we have this red triangle, and we have side H. And to figure out what H is, well, let's just label this side first. This is going to be A over 2, since this side also bisects this angle here. And we know that this is a perpendicular bisector, so that must be 9 degrees. And we already know that this angle is 30 degrees. So what's this angle? What we want to know what we're gonna call it beta. What's beta equal to? Well, we can see from our original triangle. We know that a full circle is 360 degrees, right? And we noticed that we divided the triangle into 3 equal segments. So therefore, if we name each of these angles, let's do a different color. If we name this angle, we're gonna name it. What should we name it? Let's name it this. Let's name it gamma. How about that? Yeah. And since in a full circle there's 360 degrees, we can divide 3. We can divide that by 3, and therefore this guy is equal to 120 degrees. And we know that angle beta is also half the size of 120, or namely gamma. So we can write it as this is okay. Let's erase this. We know that that's equal to this over 2, which is 120 over 2. Therefore, beta is equal to 60 degrees. Okay, now I got everything we need. Right. So if we recall the special right triangles, so we're gonna recall special right triangles. We will know that 30, 60, 90 is a special right triangle. So let's just draw it out. We would know that 30, 60, 90, and we would know that this side is 2. That side, okay, this is not a really good diagram, but you get the idea. This is 1, and this has to be root 3. And what we can do is we can actually just use ratios and figure out what uh, h could be. So this is h. So therefore we can do 1 over root 3 is equal to h over a over 2. So we're just going to solve. We're going to solve for h here, and we get that. Okay, let's see here. How can we do this? Well, we can multiply. Well, this is going to be 2h over a, right? So we can multiply this side by a and then that, so therefore a is equal to. And we'll find that h is equal to a. You find that h is equal to a over 2 root 3. Now we can put it all together, right? Because we know what h is now. And we can also just directly apply this formula. Directly apply this formula. So let's go ahead and do that. So therefore, the area of a regular triangle is equal to the area of the green triangle, which, sorry about that, the area of the green triangle, which is this triangle, times 3. And we know, okay, and we know that one of these triangles is 1/2 a times, we already know what h is. H is equal to a over 2 square root of 3. And all you gotta do is multiply that by 3. Therefore, we know, okay, so let's simplify this. We can simplify this, the top to be 3a squared, and the bottom is 4 square root of 3. And in fact, we can simplify further by multiplying both the top and bottom by square root of 3 to rationalize the denominator. And therefore, we will find that this is going to be equal to 3a squared times square root of 3 over 4 times 3. This is going to be, yeah, this is 3 right over here. And now we can see that you can actually just simply cancel out the 3. And therefore, the area of a regular triangle is equal to 3 over 4 a squared. Okay, no, we don't need the, is equal to root 3 over 4 a squared. And we are done.